Okay, very good evening, all of you. Hope you all are doing well. Let's start with today's session. In the last session, we started discussing about data cleaning. Then I told you what is data cleaning, then why to do it, the impact of doing data cleaning, and then what all things come in data cleaning. That too I've told you, if you remember. That is removing empty cells, cells in which you have left blank. Okay, then wrong format. What we want instead of that, there is something else. Like date is there and their number is stored, or the date should be in some format, but you have given in another format. Then wrong data, getting, and then duplicates. So all these four things I've told you last time. Now, how to do all this? I mean, how to remove empty cells, how to remove the wrong format, the wrong data, how to remove duplicates, how to remove all this one by one today we have to discuss. Okay, but before that, we will just study one CSV file, and in that I'll show you how all the things are coming in that. Okay, so we have that data2.csv, if you remember. Getting? We have loaded it. It was containing some 31 records. We will again load that. See, this one was there. I'll create a new cell. Okay. Before that, import pandas as PD, right? And then this data2.csv. We have already uploaded it in the last session. So this file is already uploaded on the Google Colab side. So we are reading the content, that CSV content from that file and copying it into the data frame. And you can directly print and see that data frame. Okay? We will just print it and print data frame. Okay? For the first time we are running, it will take time. Okay? Now you can see this whole data frame, which is printed with around 31 values. Now, in this data frame, we will identify all the things, all the types of cleaning targets. What are there for cleaning? These four things. Finding out what are the bad data. So I told you the bad data are empty cells, then the format is wrong, the data is wrong, like pulses you're entering. Okay, so that pulse rate you are taking for some duration, half an hour, 45 minutes, 1 minute, and someone has entered 450 only. So it is a outlier. It's going something far away from the expected. So that are called as outliers. And there are some rows containing duplicate values. So all these things we will observe in our file, which I have loaded in this file. You can check. See here, empty cells. Now, how pandas indicate it is an empty cell when it is containing nan in it. That is not a number or null value. Okay? Row number 22. The date value is explicitly missing. Okay? And rows 18 and 28. The calorie values are blank. They are also empty. Can you check which row? Row number 22. The date column. This is date column. So in date column in row number 22, can you check? The date is blank. And for 18 and 28, the calories column is blank. 18 and 28. If you see, this is 18, okay, and this is 28, and this is last calories column. So in calories column, can you see here 18 and 28 we have blank. Getting? So we have identified or spotted the empty cells. Similarly, wrong format. Empty cell identified. Coming to the next thing, that is wrong format. Wrong format you can see in row number 26. Row number 26, if you observe, see row number 26. This date is in a wrong format. It is expected to be in the quote. Can you see all other dates? All other dates, if you check, they are properly in a quote. Year, month, day. Here, what has happened? Row number 26. It is a number. We are expecting it to be what? See here, the date format is written as 2026 12/26, lacking surrounding string codes or standard packaging matching. Getting the rest of the columns you can see. All other are having a standard format, year, month. Whereas here you have written directly what? A number. Directly a number is written, not even in a code. It is not in the expected format. Okay. So we can say that data is in a wrong format. Then about the outliers. Outliers meaning what value we are expecting in some standard range. Okay. It is going somewhat too far from that standard values. The best example I'll show you about these duration. So you are entering the pulse rate for each day. How much was the pulse? How much was the max pulse? How much calories you burned on that day? And for how much duration you did the exercise. This is everyday exercise entries done. So every day, how much calories you have burned while doing the exercise? What was your max pulse? Then the standard pulse rated, the date, and for how much duration. So you can see, observe every day the duration is around 45 to 60 minutes, 45, 60 minutes. And someday you have entered 450. It is something wrong. It is a typing error. Anomalies means unexpected result. What you are expecting, something different only you are getting, and which is wrong. Okay, so that becomes anomalous result, or you can say outlier. So all the values are in the standard range 60, 30, 45. You can see even 30 minutes, 45 minutes, 60. And somewhere 450 minutes is impossible. Means that day entry is by mistake done wrong. Either it is 45 or 60, whatever. So that is also identified. See wrong data, outliers or anomalies. Row number 7. Can you see? Row number 7. The duration is listed as 450 minutes. And if you see all the other minutes entry, the remaining entries, giving the surrounding values fluctuate logically between 30, 45, 60. All the other are half an hour, 45 minutes, 1 hour. Getting? So sure, this is a typing error. This is highly likely an input mistake. Example, a missing decimal or accidental extra zero. You are about to enter 45, but by mistake you have entered zero. So these things happen in examinations and all when we do manual entry and all. That's what nowadays everything is becoming digitized. No? Now what they are doing is directly your answer papers are scanned in 10, 12. You are not supposed to check it on that hard answer paper, hard copy. Directly the answer paper is put on the digital system and on-screen marking system is on the screen only the paper comes. There only you have to tick mark and give the marks. So the system only will calculate the total and put it so that no manual entry mistakes are there. Get it? But possible like this entry is coming from different survey forms. You have created some survey form and then that Google Forms you have given to many people and then you are collecting the data for your analytics. So that time the person might have entered the wrong data. Correct? So that is one. And last is about duplicates. Okay, so you can see in some column there are duplicate or the entire row is duplicate. Okay, see here. Row 11 and 12. Both rows share identical records across all variables. Row 11 and row 12, if you see. Correct? So this is wrong because same day, same 60-hour entry, everything's same. Max pulse, the standard pulse, how much calorie you have burned. So this is also a mistake. By mistake, you have done the same day entry twice. Okay, so keeping the duplicate is overall going to affect your statistical output. So such duplicates are also to be removed. So I hope you have identified record 11 and 12. Both rows share identical records across all variables. Variables means the parameters. Your first parameter is the time, duration. The next parameter is the date. Then the pulse, the max pulse, then the calories. All are exactly same. So in short, in our CSV file, which we loaded, all the four types of uh, data cleaning, the bad data for data cleaning are identified. The empty cells are identified, the wrong format is identified, wrong data is identified, and duplicates. So if you remove everything from our CSV file, then that CSV file becomes eligible for further analysis work. So that is the task of a data engineer, whose job is to make that data useful for the analysis so that the next analytics work can be done, the graphs can be plotted, the predictions can be done, patterns can be found out, the patterns can be guessed. So all that can be done when the data is clean, correct? So I hope this part is clear to you. Okay, so can you tell me in the given data file, are these all four things identified by you people? Whatever data file I gave, okay? Did you observe like in date column, row number 22, there is none, means blank cell. In calories column also, in row 18 and row 28, there is none, means not a null, means not a number, means blank only. You have left a blank, but when you're showing it, it is shown as none. So these are empty cell category. Then wrong format is this one. See here. Row 26 for date column. You have directly given a number. Whereas the other dates, if you check, they are in that format, year, month, day. This is not in a correct format. Then the wrong data, getting in the duration column. So you can see all other are in the range 45, 30, 60, and suddenly 450. Okay, I gave you an example that in the building, every flat are on an average earning for the year from 10 lakhs to 15 lakhs, and someone's yearly income is in crore. So it is an outlier. I'm giving an example of an outlier. Getting? So on an average, mom knows that as many people are staying in home, everyone is going to eat one chapati, two chapati, three chapati. Okay, maximum one, two, three, one, two, three. Done. But someone suddenly, one person is eating 10 chapatis, 15 chapati. It is not fitting in the category only. No? Standard is one, two, three, one, two, three, and someone is saying, no, I am going to eat 15 chapatis today. So it's an outlier. It's a value not in the limit. Correct? So this is 45. And then the duplicates I showed, record 11 and record 12. Everything is exactly same. Can you see? The times are same, the date is same, the pulse is same, max, and the calorie. So one is to be removed so that the overall statistical result come good. Okay? So all these things, how we will remove one by one, that we are going to see. Okay? So is it clear to you guys? Is the identification clear? Just tell me quickly. Means have you observed this data in that data2.csv? All these four things, four bad data. Yes or no? So next we will be seeing how to handle empty cells. Okay, so different ways are there. Either you can remove that cell instead of cell, the row, the entire row in which empty data is there. Okay, or you can replace it with some other value, right? So both provision is given. Then with what to replace a fixed value, or you have to take the mean of the surrounding value and then replace it. Like in this case, sorry, not here. Okay, this for 450 if I want to replace. So I'll take the mean of all and then whatever comes that I try to put. So depend. NAN also. In case of NAN, I'll take the mean of all the other calories and replace it here. Either I'll remove the row only, or if it is not going to affect, if you have large record, so removing one row with a NAN will not affect anything in your statistical result. Getting? Otherwise, you can replace it with some value. Now, replacing a hard-coded value or taking the mean of the other values, whatever other values are there, take the mean of that and replace it with a mean so that you get the value, not an outlier. You'll get in the surrounding result. Okay, so different ways are there how to do it that we will see. So first part we have to see handling empty cells. Okay, now how does Panda identify that it is a blank cell? So empty cell often loaded as nan or null in Pandas. Okay, so in your data frame, if some cells are having nan, it can lead to inaccurate conclusion or errors during data analysis. Is further, suppose you want to take the entire column mean, or you want to take that entire column deviation, standard deviation. Okay, so different statistical work on that column I want to do. So if the column contains none, it will not give you a correct result, or sometimes it will give you error as well. If the column contains none, NaN, not a number. So what to do? Either remove it or replace it with something. How to do it? I'll tell you. So there are two main approaches to dealing with empty cell. First, remove. So remove means you have to remove the entire row containing nan. Pura row ही निकाल दो. The entire row you remove it in which nan is there. Or replace the empty cell with an alternative value. You put in place of it some another value. How to do it? The first part we'll see. That is the removing. Okay. So you can remove the entire row, the complete row in which some column is having a null value. Okay. So for that we have drop any. Drop any is a method of data frame. It is a method of data frame. Data frame has provided this method. Make use of it. Okay. So first part is what that I told. Remove the rows containing empty cell. Or second option is instead of removing the row, replace that nan with some another value. How to replace that also I'll show you. We will discuss about the first one, removing the row. How to remove the row? By using this drop NA method. Okay? Now, if your data set is large, means in your data set there are thousands and lakhs of records, then removing any row containing nan will not affect much. Okay, so dropping few rows with missing values usually does not significantly impact on the overall analytical result. Overall result पे इतना कुछ effect नहीं करेगा. Already, suppose you have collected around 1,000 records, and in that one or two are having blank. So removing that blank row will not make much impact. Huh, but if you have less record, and in that if you have blank rows, then instead of removing, try replacing it. Okay. So मैंने कहा कि what to do? In the first case, remove. How to drop it, that we will discuss. Okay? See. And in that also we have two options. That is whether to do it in the original data frame or whether to return a copy. Both are there. Okay. So there's one option where data frame dot drop any. Okay. And you don't pass anything. Then what it will do, it will return a copy data frame. Original data frame will remain as it is with nan. It will return a new data frame in which that nan containing rows are removed. Okay. And otherwise there is one option called in place equal to true. You can pass one parameter called in place, which is a keyword parameter passed to this drop any. And in place equal to true, if you do, it will not return a new data frame. Instead, it will do the changes in the original data frame. Okay, so both provisions are there. We will see practically as well. See. So first is returning a new data frame. By default, drop any. Okay. By default, your drop any method returns a copy. It doesn't do any change in the original data set. It returns the copy set. Original data set will remain intact. Okay. But the copy which you get in that, all the rows in which nan is there are removed. Okay, so returns the copy of the data set with empty rows removed, leaving the original data frame untouched. The original data frame will remain as it is. It gives you the new data frame. See here, example. Now the first two lines I did not tell you. You have a CSV file and you are loading that CSV file in the data frame. How to load a CSV file in data frame? By read CSV method of your Pandas library. So pd.read_csv, give this. Okay, it reads it, puts it into the data frame. Now you're writing df.dropAny. What this drop any will do, it will check in the data frame all the rows in which at least one value is nan. So in any row, if there is the nan value, that whole row is deleted and you get a new data frame. You can print and see that new data frame. Okay, if you want, I'll show you that too. Now we already have this data frame. Okay. Okay, we already have that data frame. So I'm writing new data frame is equal to df dot drop any. Okay. And you can print and see that new data frame. Whatever that data frame is, you can check. So these records like 28, 22, then this 18 should get deleted. Okay, I'll add that again over here. Problem. I'll just create that code again. Import pandas as pd, then df equal to pd dot read csv, and then I'll give that data2 dot csv. Okay. Run. Okay, so it is not, it is saying Okay, no problem. We have the code of uploading it. Maybe it is for every session, it might be dropping it. Uploading logic we have. See this one. So I'll just upload this again. Okay, it's done. Now we will run this code. See, okay? And now when you're printing which data frame, guys, the new data frame. Can you see those all rows have gone? Which row number? 18 row number, 22 row number. Can you see here the 18 row number is gone. 16, 17, direct 19. 18 is not there. Even 22 is gone. See 21 and 23. 22 is gone. And one more was there, that is 28. So can you see 27 and 29? 28 is not there. So this way, what is done? All the rows which are containing nan are deleted. But it has not done in the original data frame. It has returned a copy data frame. But if you want it to be done in the original data frame only, then to drop any, you pass this parameter. This is a keyword in place, which is by default true. By default false. In place is by default false. That is why it is not doing in place. Right? It is returning a copy. In place means doing the activity on the original data frame. So I am writing in place equal to true. Okay? So to permanently remove those rows from the original data frame directly without saving it to a new variable. You don't want that data frame in a new variable. It should do it in the original. Use in place equal to true. Okay? See here. The same thing. I'm loading the data frame, that CSV file into the data frame, and then df.drop any in place equal to true. Okay. If you want, I'll show you that example. See, I'll create another cell. Now, original df we have. So I'll just write df dot drop any, right? And then in place equal to true. In place equal to true. Okay. So in the original data frame only it is gone. Now if you print and see that data frame, and if you want, before doing this also, you want to print and see the data frame. See, before dropping any and after that, see, before dropping, you can check there are NaN values in 18, 22, 28. Okay. And when we did df dot drop any and in place equal to true, in the same data frame, those null values are gone. Can you see the 28th row is gone? Then the 18th row is gone. 22nd row is gone. Okay, guys. So I hope you're understanding that. Okay, clear to you. Then the next strategy is what I told you, to handle empty cells. There are two options. One, to drop the whole row only containing blank value, right or no? To drop that entire row only which is containing blank value. In that also I showed you, like drop any which is doing the change in the original data frame or returning a copy data frame. Okay. Now second option, what I said, instead of dropping that row, replace it with some value. Okay. You can replace that cell with some value. Okay. So for that they have given fill any, right? So replacing missing cells prevent the loss of valid data present in another column of the same row. There are chances that in that row, somewhere you have NaN. Getting? but other column values are useful. So instead of deleting the entire row, replace this nan with some value, replace this nan with some value, and then continue with the work instead of dropping. Then we have to use this fill nan. Okay, so replacing missing cells prevents the loss of valid data present in other columns of the same row. Okay, now first way is global replacement. Global replacement means replace all the nan with one fixed value. Some fixed value is there and replace each and every nan with that fixed value, which is sometimes not acceptable, right? See here, you can substitute every missing value across the data frame. In that entire data frame, wherever nan is there, replace that nan with one fixed value with a single placeholder. As an example, see that file CSV you are loading in the data frame, and then you are writing df.fillAny 130. And here also we have option. If you don't give in place equal to true, then in place is false. And as it is false, it is going to return a copy data frame. It will return a copy data frame. And if you don't give in place equal to true, copy. And if you give, it will do in the same data frame. But in this case, what you're observing, all nans are replaced with 130. But sometimes it becomes funny or it is meaningless to replace every nan with same value. Okay, like in calories column, if there is nan, I can replace it. But in date column, nan replacing with 130 is something weird. Or in time column, duration. Getting no? In the duration column, replacing it with 130 is also wrong because our durations are 40, 5, 30, 60. So somewhere replacing related value is okay. Putting this constant is not valid. But provision is there. Okay, we will do that. I'll show you. See, first we will load that data frame. See, we will get the data frame. Check, guys, carefully. Okay, the data frame is loaded. We are printing that data frame. And then I'm writing df dot fill nan. Okay, so continuously we are learning new methods of data frame. Sometimes we saw head, tail, then info. You remember? Now some new things are getting added. So df dot fill any, and by what to fill that you have to give. Like I'm filling it by 130. And if you want to do it in the same data frame, give in place equal to true. And now print and see this new data frame. The old and the new after modification. See, you can check. This is our old data frame, which we loaded from the file, CSV file into the data frame. So there are many places nan are there. Can you see in 18th row, then 22nd place, then even in 28th row, right? Now what I'm doing is I'm doing fill any 130. But as I've written in place true, in the same data frame it is doing. So we are printing that data frame. See. Afterwards, can you see every nan is replaced with 130? This 18th year it was nan, it is replaced with 130. 22 year there was some nan to 130. Even in 26 also somewhere there was 26 or 28. 28, right? Here it was nan. Okay? You're understanding, no? Yes or no? Can you see in calories column at two place there is nan? Here replacing 130, 130 is meaningful. But in date, replacing nan 130 is not making a sense. Here it is not making a sense replacing it with 130. But replacing in calories column by 130 is okay, right? So sometimes global replacement doesn't make sense. So you can replace a particular column only, not the entire data frame. Not the entire data frame you are replacing nan with some fixed value. Instead, you can replace one particular column nan value with some value. Correct? So that provision also they have given. Targeted column replacement. Okay? So how to do replacement in one particular column only? So to limit replacement to a specific column, pass a dictionary mapping the column name to new value. So here we have passed 130. Instead, pass here a dictionary in which the column name is there and the value for that column. So here what I'll write, a dictionary brace bracket. The key will be calories and the value will be 130. And this thing I'll pass to fill any. In place of 130, I'll pass this dictionary. Now what fill any will do? Will it do the global replacement? Entire data frame NAM will be replaced with 130 or only in the calories column? सिर्फ calories column में in the calories column it will replace nan with 130. Okay, ठीक है? See again df dot fill any. I'm passing that dictionary and in place equal to true. In place equal to true meaning do the changes in the original data frame. Don't return a copy. That is the meaning. ठीक है? See you now. I'll create a new cell. Now, instead of 130, I'll create a dictionary. Key is calories and value is 130. Okay. And now you can check. See guys. In the output, can you see in the original data frame, 3 places we have nan. 2 in calories column and 1 in date column. But as we have used targeted column replacement, not global replacement, targeted column and as well as in place. So in the same data frame, the changes have happened and you're printing that data frame. Now can you see in calories column only 2 nans got replaced with 130. 18th row and 28th row. But the date nan has remained as it is. Okay, yes or no? Can you give me confirmation, guys?
Yes, sir, it's clear.
Sure. Others are joined or no, I don't know. Okay? Then moving ahead. Then there is another way of replacement. Now, okay, we have replaced it with the fixed value 130. First, what I did, first what we did, we removed the rows only by drop any. Using drop any, what we did, we removed the entire row, right? But then in that also, the copy or the original, that concept are clear. But dropping row every time is not feasible because sometimes in that whole row, the other columns may be having meaningful data. So removing the row, instead of removing row, replacing only that nan value with some other value is better. So in that we saw global replacement. What was happening in the entire data frame, wherever nan is there, it is getting replaced. But in that case also global replacement will be sometimes funny where the column should not have that value. It will get something weird value like date column. So that date should come, but in date column nan, some 130 is getting replaced. So targeted column should be there. So how to do targeted replacement? To fill any only, give the dictionary in which the key is the column name and value is the value what you want to replace. But again, sometimes filling that column with the same value won't make a meaning. Fixed value 130, 130 is not right. Sometimes it may give you wrong statistical output. So in that case, what is suggested? Okay, take the mean or mean, that is the average or the deviation, mean you can take, and mean of the other values you take and replace that with the mean so that the overall statistical output will be good. Get it? Because you have replaced the value which is not an outlier. It belongs in that boundary only. All the calories which you have entered, they are in the standard range. So this replacement also will be in that range only, no? Because you will be taking the mean of all that value and then replacing it, isn't it? Okay. So advanced replacement with statistical metrics. This metrics means measurements. Huh? When we write a metrics, means that means measurements. Okay? So one way is replacing that with the median or the mode or the mean. You'll say, what is median, mean, mode? I'll tell you. Okay. A mathematically sound way to handle missing continuous numeric data. You can see in the calories, all are continuous. Huh? Calories are in the range 200, 300, 400. In that range only the calories are. So if in that range, if someone is missing, replace the value which belongs to that range only. उसी रेंज में जो वैल्यू है वो रिप्लेस करना बेटर है. ओके, तो सेल्स विद द कॉलम्स मीन, मीडियन और मोड. So one way is take the average of that all other non-null values, whatever non-null values are there, take the average of it and replace that none with the average. Median is the middle value of the sorted data. Is whatever data you have, like you have 8, 7, 15, 12, getting 18, 11, 20, whatever. You have to sort them. Sort means 7, 8, 11, 12, 15, 18, 20. And then the middle of this sorted data. So as it is odd, so the middle value is 12. If you have even, so you have to take the mean of the middle two. So suppose example one more is there, that is 26. 26. So what will be the median? Sorry, what will be the median? The middle two. Getting this 3, this 3. So middle two is this. You have to take the average of it. That is 12 plus 15 by 2. So 27 by 2. 13.5. So 13.5 is the median. Replace that by the median. Okay. Mean is taking the average of all. 8 plus 7 plus 15 plus 12 plus 18 plus 11 plus 20 plus 26 and divided by the number of values. Take the average and then divide it with how many values? 3 and 3, 6, 8. So whatever total you get, divide by. That is the mean. And now you'll say what a mode. Mode means the frequency, means how many times each element is occurring. Each element is occurring how many times. Okay. So we will be discussing all that. First is using the mean. Mean means the average. Okay. So first of all, what do you mean by average? Average is the sum of all the values divided by total number of values. I hope you understand this definition. Average concept, I hope you know it. Like 2 is there, 5 is there, 3 is there. Okay. Then 4 is there, and then 1 is there, suppose. So what is the total? Getting? So 5 and 3, 8, 10 and 5, 15. So 15 you are going to divide by how many values? 5 values are there. So 15 by 5, 3. So 3 is the average for these 5 values. The average of these 5 values is 3. Getting? So replace that nan with the average of the other value, the sum of all values divided by the total number of values. Okay? See, as an example. Now, how to find out mean? Very simple. df of column name you give, you have data frame. First part I need not tell you. From CSV, you have read that CSV and loaded in the data frame. Now, particular column, if you want, just write df of column name. It will give that series, guys. See, here also, if you want, I'll show you. Okay? Instead of printing the entire data frame, you can access the single column as well, guys. See, when I'm printing, the whole data frame is coming. Instead of that, if I write df of calories, so it will only print that column as a series because each column is a series. See, is it printing only that column? And the column name becomes the series name. Okay? Same way if I write date, so only that column date will be printed. Okay? So with this, you get access to that column, right? When I write df of date, I'm getting the entire column, which is a series. And then there are methods of series. Series methods are there, like mean. Now, what this mean method will do, it will return the average of all the values in that series. Remember, this whole thing is the data frame. But when you write only one column, then that whole column will be called as a series. So this is the method of that series. So what it will do, it will take all the values of that column and then it will apply mean on that column. You'll get the answer. You can collect it. And then that answer, you replace it. So instead of date, we will take calories. I'll store it in some variable. And then what I'll write? df dot fill any. ठीक है? Targeted columns, I said calories colon x. And in place, if you want, give. So now what will happen, guys? Will it take the mean of all the values in calories column? In this whole calories column, as many values are there. It will take the mean of that. Mean means average. That average you got in X. And then you are replacing that average. You are replacing that average in place of nan. But which column? In place of nan. In which column? Calories column. So in the entire calories column, wherever nan is found, again nan is found, it is replacing it with the average. Okay? See here. Now I'll print that data frame. Getting, guys? If you want to check what the average is and has it really replaced that average, you can print that X also. Okay? See here. That X is 304.68, right? And in the calories column, here the spelling went wrong. Okay? Again, no. 304.68. Now come to this calories column. Can you see all that columns are gone where nan was there in 28th row, then in 18th. Has it replaced it with 304.68? 304.68. Getting? So this way you can do the replacement. Okay, guys? Give me confirmation. So sometimes it is advisable that to replace that nan not with a fixed value. It is better to, because sometimes when you fix that value may be a outlier also. No? Like generally the calories burned every day of that person are in the range you can see around 200 to 400, 200, 400. And if you are replacing it with 1000, it is what we say, we cannot believe it, unbelievable, we'll say. It is unbelievable, believable. Unbelievable is not to be put over there because every time the calories are in that particular range for that much duration, how can directly someday 1000 can come? So you cannot replace that nan with some fixed value. Sometimes such techniques are to be applied, like calculating the average and then replacing it with the average so that your ultimate statistical result will come accurate or perfect. Now, using the median, in that case, what it does, it sorts all the values and then takes the middle value. Median means you're understanding the middle value. Like 7 is there, 9 is there, 12 we have got, 22 we got, okay, 26. They all are arranged. Okay? And then take the middle. If there are odd, only one middle is there. But if there are even, then two middle will take, add them and divide by 2. Like here, suppose one more is there, 30. So we have to take this middle 2 and divide by 2. Getting? So it is 34 and then 34 by 2 comes 17 and 17 will be the median. So they say replace that nan with the median value. वो nan को किससे replace करो? With the median, CM. So what is first median? The middle value after sorting all values in ascending. When you arrange all the values in ascending order, and after arranging what the middle value you get, that is the median. Okay. Now again, how to calculate median? Use median method. You don't bother. Internally, it will sort that column. Whatever that calories column is there, it will be sorted. And after sorting, the middle value it will return. And if there are even, it will take the mean of the middle two. If there are even value, so it will take the mean of the middle two. Middle two are A and B. So it will take A plus B by 2. Getting? And if it is odd, then you have only one middle value. That middle value will come in X. And then you replace it in that column, every nan with that median value. Understanding? Yes or no? This thing, can you give me confirmation? Sure. See. Again, in this column, this mean, median, these are the methods of series, guys. Actually, they are methods of series. That's why we are applying only on that individual column. Getting? So from the file, the data frame is loaded. Okay. From the file, the content is read, they are put into the data frame. Now df.calories, and we don't want mean, I want median. That median value you will get here. Even there is method called dot sort. It will sort it and give you a new column. That median we are printing. And then what I'm doing is I'm replacing all the nan values, means I'm filling all the nan values in calories column. Which column? Only calories column. I'm replacing all nan with that X, where X is the median. And I'm doing in place replacement. I'm not returning a new data frame. I'm doing the changes in the original data frame. Okay? See here. How much mean you got? 291 point meaning median. The median value what you got? 291.2. ठीक है? If these all values are sorted, this original in which nan was there, this one. If you sort them, the middle value you get as 291.2. Now you are replacing in calories column all nan with this 291.2. You can check here. See here. 28 row calorie was nan replaced with 291.2. 18 was also having nan. It is replaced with 291.2. Getting, guys? Actually, it is
Yes.
having 32 values. No? See, how many rows are there? 31 rows. So total values are 32. So middle value you'll get from middle to divided by 2. Therefore, you got 291. Okay? And third, you can replace it with the mode. Now, mode means what? The most frequent. The value which is most frequently occurring, maximum time occurring. Okay. So the value which is occurring most frequently, that mode returns. But sometimes it may happen that more than one value is occurring more frequently. It will return a list. Understanding? It will return a list. I'll show you that. We will not do replacement. First, we'll just calculate the mode. See. So from the file, we loaded the data frame of calories dot mode. Now X will not be a single value, guys. It can be single also, it can be more than one, but it is going to be a list. Getting? And in that list, what will be there? Those all values which are occurring more frequently. If you print and see, getting? In that X, what is coming? 300. Now that 300 is the value which is occurring how many times? Maximum time. But that x is not a scalar value. Only 300 is not coming like here. Here we got that x as a scalar value. 291.2. Here also see that x is a scalar value. 304.68. Here it gives you a series. And in that series, how many values are there? One or more. Means if there is one more value which is also frequently occurring, so you will get two values 0, 300 and 1, 252. Understanding? You may get output like this also. In 0th place 300, 1th place 291. Now this says what? That in your data frame, they both are frequently occurring. The maximum frequency of who is more 300 and 291. So from this take any one and replace it. So if I want any one, I have to write square and access segment. Square 0 if I write, I'll get this. Square 1 if I get, I'll get the next value. Okay? See here. So what is the mode? The value that appears most frequently. And I guess you might have studied somewhere in statistics. If you have done your engineering or BCA or BCS, somewhere stats paper is there. Everyone had. In engineering also in M3 they have. Even for BCA, BCS also. BSc Computer Science or plain BSc if you have done. Stats is a very favorite subject. This is called a central tendency. Getting? Or descriptive statistics. So definition is the value that appears most frequently. See here. But remember, mode doesn't return a single value as we got in the previous case, like median. So median is going to be one value only in that whole series, in that whole column, in that entire column, one value only will be there, na, the middle value. If there are two, we take divided by two. Add them and divide by. So only one, that is a scalar value. But in case of mode, you will get a series in which minimum one value will be there. Like 0, 291 come and 1, 300. So in this series, if two value are coming, means it indicates that in that column, there are two values which are appearing more frequently. The frequency of 291 and frequency of 300, both is highest. Okay. So mode returns a Pandas series because there can be multiple modes. So you need to grab only one. So you write square for that series. After mode, you got a series like this. Mode has returned a series. And from that series, I'm accessing the zeroth value from that series. So you'll get 291 and then that you use it for replacement. Okay? See. Can you see df.calories.mode? It has returned you a series containing how many values? One or more, which are frequently occurring. Minimum one value you will get or more also. But from that, I need the first one. So I'm taking square 0. You get it. And then replace it by fill in. Okay? Hope it is clear, I guess. See, in this case, you can check what I printed that X. Did it print a series containing one value at 0th place 300? Therefore, that series we don't want. In that series, the 0th value we want, which is the most frequent one. So I'll take off 0 and then if you want, you can print that and then df dot fill any calories colon X and in place equal to true. And now you can check your new data frame. Okay. So in that new data frame, you will see in calories column, like 28th column, 18th, 28th row, then 18th row where nan was there will get replaced with that most frequent value. Check here. Can you see 28? Is it replaced with 300? Why? Because 300 is the most frequent one. So in 18th row in calories column, is that nan replaced with 300? Again here, is it replaced by 300? Okay. So hope this part is also clear to you. Okay. So we have done with the first part in the data cleaning mechanism. What is that first part? Handling empty cells. How to handle empty cells. So in that we saw two strategies. One, remove the entire row in which what is there? Nan. Wherever nan come, that whole row only you delete by using drop any. One strategy. Second, instead of dropping the row, fill that nan with some value. In that also we saw that replacing it with what? Okay, so global replacement, then all will get. And particular column, then use that dictionary and do it by using fill any. And then I told you some advanced replacement technique that instead of replacing it with a fixed value, use some central tendency, your descriptive statistics. So calculate the mean of that column and replace that blank, that nan with a mean, or take a median sorted value and the middle value and replace that nan with the middle value, or replace it with the most frequent value, the value which is most frequently occurring, that is mode, replace that blank with that value. Okay, so I hope you're understanding. Is it right? Just give me confirmation. So that will move to the second data cleaning. That is wrong format. Then third is wrong data. And fourth is eliminating duplicates. Right, guys? So one part is done. Now moving to the second part. Sure. Second part is cleaning data of wrong format. The example I told you, the data in the wrong format. If you consider this date column, see, if you check all the other formats, they all are in proper format. Year, month, day, quoted in single quote. But somewhere you're getting only a number. Can you see? A huge number is there. This is not advisable. Okay, so what to do? So there is a function which can convert this number to the date format. Use that. Okay, so there is a function provided by Pandas library. They are date category functions which take input as this number. They will treat it like a timestamp. It will treat it like number of milliseconds or seconds elapsed from the start of a calendar. From when the calendar started till now, it will consider this like a timestamp and it will convert that into a proper date. Okay, so that is also possible. But in this process, what will happen is when you are trying to convert this value to date, what about NAN? When NAN gets converted to date, it becomes NAT. There is not a time. So after replacing this with a formatted date, still you have such values, that is NAN converted to NAT. Then remove that row, drop that row, getting by using drop any. So cleaning data of wrong format. See here, inconsistent formatting, such as numbers mixed into text column. You have a text column like name. Suppose you are keeping information about all the employees, employee ID, employee name, their salary, their phone number, whatever, in that data set, means in that data frame. So now the column is name. So we know that everything should be text. So in that someone has entered numbers. Getting mixed into text column or malformed dates, which I gave, where every date should be in a proper single quoted, then year, then month, then day. And instead of that, someone has entered a wrong number in the place of date. So keeping such data can give you wrong statistical output, can make accurate statistical analysis difficult or impossible. So what to do? To standardize a column, standardize means consistent values are there in that column. In that entire column, all the values are consistent. Like all values are numbers with a two decimal. Like this, if you see, all are numbers with a two place, one place decimal. It becomes consistent. Okay. Like if you consider this pulse and max pulse, all are numeric. Okay. But in this case, date, if you see, somewhere you have a number in place of date. Getting? So this is creating an inconsistency, which will give you wrong statistical analysis. So how to standardize that column? Means all the values in that column are satisfying a fixed format. All values are in a fixed format. Okay. So you have two primary options. One, use some formatting function and convert it. See, convert all values in that column into a unified correct format. And for bringing them in the correct format, Pandas has given methods. Don't worry, we'll learn that. Okay, one, or either delete them. Second, remove the row containing unflexible data. As the data is not getting adjusted to our format, we are saying this is my format and this data is not getting accommodated to our format. It's better to remove it from that so that all the values will be in a standardized way. Getting? So both options we will see. First is convert. And to convert that value into the correct format, there are some formatting function. In our case, we are using to date because we have a wrong data in the date column. Isn't it, guys? In the date column, we have a wrong data. Therefore, we have to do formatting on date. And therefore, I'm using this date related pd.toDateTime. Okay. So convert to a correct date format by using this pandas function. See, while handling date formatting discrepancies means there are inaccurate discrepancies, meaning in your column there are everyone in a correct format and someone is not. Pandas provide a specialized method called pd.toDateTime. So now if you pass that number, there was a big number over here, this one, sorry, this one only. When you give it to this function, it will convert it into some date format. And whatever date you get, replace it over there. Okay? So see here, in the sample exercise data set, which I have given, this data set, the date column contains two anomalies. One is that blank. Anomalies means you're understanding, no? Anomalies means what we are expecting, you are having something wrong in place of it. What we want, instead of that, there is something wrong in place of that. So it is an anomalous thing. When we get something unexpected output, what was expected, the standard, and something different only you get, that is anomalies. Right or no? Like in the paper mark sheet, we know that expected marks are this much only. And in place of that, something weird values are getting printed. Maximum you will get 100 on 100, right? Maximum zero you will get, minimum. But they're printed 1000 in place of 100, 1000 is printed. So that are discrepancies. Okay, so that you can replace it. So the date column contains two anomalies. One is this blank value and another is this wrong number in a date column. Right? See, row 26. The value is structured as an unquoted raw integer. Can you see? Actually, if you check, it is 2022 12 26. It is 26th of December 2022. But whoever was entering the data forgot to put a dash over there and it is treated as one single number. Okay, row 26. And second, the value is missing, blank value in row number 22. So both are to be brought into the correct format. Both are to be brought into the correct format. And when you bring them in the correct format, this becomes standardized, which will be useful for further analysis. Isn't it? Okay. So what we do is that column, that date column, we give to this date time. Okay. See here, by applying pd.toDateTime, pandas dynamically, there is runtime, convert, okay, all those integers into the proper date format. Translates varying string or integer styles into a uniform date format. Okay, how to do it? See here. pd.toDateTime. This is pandas function. It is not a method of that data frame. It is not a method of the data frame. It is a built-in function in that pandas library. It is a direct function present in that. So pd.toDate, then give the column on which you want to do formatting. Which column? The date column. Is it a date column of your data frame? So will it be a series, guys? Is it going to be a series? Only particular column you're passing, no? to date time. The particular column of a data frame is a series. So you're passing that series. You're telling that in that column there is a mixed formatting. Mixed format is there. Somewhere number, somewhere string. Okay. So format equal to mixed. Which column you passed? The date column, which is a series. Now what it will do in that column, all the discrepancies are replaced with a date and you get a new series. You will get a new series. That new series, you are replacing it in the original data frame. In which column? Date column, df of date. Which series will get replaced? The output series. Okay. And then print your data frame. I told you while printing, every time it is not mandatory to write toString. Understanding? When we generally write toString, when the output contains 60 or more columns, with more than 60 columns. When output column, very sorry, rows, more than 60 rows, then to print everything, you write toString. Otherwise, what it does, head and tail, first file, last file. Okay, so I hope this part you are understanding what it is doing. What it is doing, it is taking which column? The date column of the data frame. Date column is it's a series. That series we pass to this function to date time. And then what it will do in that column, as many discrepancies were there, it will convert them to the date format and give you new series. And that new series we are replacing in the original data frame date column. In the original data frame's date column is replaced with this new series. Okay? Okay. See here in our example. First, the data frame we got loaded from that file. Then I'm writing df of date equal to pd dot to date time. Then I'm passing one column. That is which column? Date column. Format equal to fixed. Right? So it will take the old date column, this column, old date column. That column is a series. On that, it will do the formatting. Means it will convert the number to date and give you new column. And that new column you are replacing in the original data frame in that date column. And you can print and see that data frame. But if you see the output, if you study the output, you'll see still some discrepancies are remaining. Let's see. Okay. Mixed format equal to fixed mean mixed values. Very sorry for that. Okay, see. Now if you check this date column, can you see that the 28, I guess, or 26, you can see the older one, 26, this value. Is it changed? See, 2020, 12, 26. Is it converted to the correct format? But when it tried to convert that NAN to date, so NAN cannot be converted to date. Therefore, still you have a blank value that is called NAT. Now, NAT says that it is not a time, not a time. So again, if you want to make this column consistent, get it? So you have to go for the back point, that is removing empty cell. So again, you have to apply that, finding out the empty cell and remove. So in this column, remove that whole row only where that NAT is there by using drop NA. So what will drop NA do? We'll remove this whole row and then this column will become a consistent column. Get it? See here. The results of conversion. After conversion, we saw that whole number was there. got converted into date. But what about that NAN? That NAN didn't get converted to date. And there, instead of NAN, NAT is replaced. See here. Row 26. Here the successful conversion is there. The raw integer, this one, 20201226, is successfully converted into a standardized format. Getting guys? But row 22, where initially there was NAN, when we tried to convert it into date, it became NAT, not a time. The missing value NAN evaluates to a special native pandas timestamp called not a time. So again, keeping that not a time is not good practice, no? Because your column has not come consistent. And for good analysis, that whole column should contain a consistent data. It is a part of data cleaning, right? So what is the option for this second NAT? Drop any and remove that whole row. Getting? So I hope you got it. The first part is clear to you. The first strategy was to replace all that inconsistent data with a correct date format. But there is a chance that some values cannot be brought to that date format. Then what do you do? Remove that row, which is NAT or NAN, by using drop n. Getting? So to avoid accidentally dropping rows where other columns are empty, like in this case, if I use drop any here in this case, actually I want to remove only this 22 row, है ना, in which this NAT is there. Only this so that this column become consistent. But if you directly call drop any, it will remove this row also. Which row? This one. And it will remove this row also. Whereas that row, instead of removing, you can replace it by mean or mode or median. But what will happen? If you are writing drop any blindly, it will delete this row, which you want to. But along with that, these rows also will get deleted. Okay, so you can delete only the specific row. How to do it, that we'll see. So see here, to avoid accidentally dropping rows where other columns are empty, okay, use the subset parameter to focus specifically on rows where only the date column is invalid. Means only whose NaN is to be checked, that particular column NaN. Don't worry about the other column blank value. Because I said now the other column blank value, you can handle it by the previous technique which we saw today. One technique, remove the row. Second, replace it with fixed value. Third, replace it with some statistical value. With that, you can handle. So in this only, these rows should not get handled. ये वाले rows के handling की जरूरत नहीं. Only handle this row. So how we can do it? So which I said, specify that specific column. Okay, see here. So after conversion also, after converting the date column to the date time format, still you are having one column, one row in which NAT is there. So how you can do? Use drop NA only, df.drop NA, but use this subset parameter and to that pass the column name. So as you are passing column name date, it will drop only those rows in which date column is having NaN. And in place, I hope you know it. Writing in place true means it does in the original. But if you don't do this subset equal to, will it remove all the rows in which NaN is there? All row. So in that, what will happen? This 18th will also get deleted. This 22 will also get deleted. This 28 will also get deleted. But in this case, while deleting 22, there was no need to delete 18 and 28 because this we are going to handle differently. ये nans को हम अलग way से handle करने वाले हैं. How we are going to handle it? By replacing them with the average. Getting? So only this row we wanted to delete. Therefore, while dropping, we are mentioning the specific column name in that subset and then print your data frame. Okay, getting guys? I hope you're understanding.
Yes, sir.
Let's see. I'll show you over here. In this only we will do further. Df dot drop any, and you have to use subset square date, and you want to do it in place only, give in place equal to true. Okay, and after that you check your data frame. First, after doing the date time formatting, you got a data frame, but still in that data frame the date column is having NAD. Now that will get removed after this. See, this was the first part after doing formatting. So after doing that two date time formatting, can you see this 26th value, which was a number, got converted to date? But this is still persisting, this NAT, because two date time was not able to convert that blank to a date and time. Therefore, it has replaced it with NAT, that is not a time. That we removed, that whole row only we removed by this drop any. But only which row we are removing? The row in which date column is having nan. We have mentioned a subset equal to date. If you have two separate columns, date and suppose calorie, so right here, comma calorie. So only in those two columns it will consider. Understanding? So in the next output, can you see that row 22 only is gone? 21, 23. Is that entire row 22 gone? But the other nans are there. In calories column, we have nan. They're still there. Because that you can handle it in different way. In that case, there is no need to drop it. Getting? You can replace them with the average of all, or you can replace it with the median or with the mode value, right or no? So every column, the applications are different. How to handle them is different. Okay? Then what was the third thing? That is fixing wrong data. Wrong data means you have put an unrealistic data. Unrealistic data. Like in calories column, on an average 200 to 400 every day, 1 hour workout, half an hour to 1 hour workout if you do, then on an average, that person is burning 200 to 400, maximum 500 calories. But there's some day, the same time, 45 minutes only, 1 hour only, and you have entered 200 calories. Whereas you are supposed to enter 200, sorry, 2000 calories. You were supposed to enter 200, but you have put 2000. Mistakenly, one zero has come. So, sure, it is a wrong data. Getting? Like in the duration, every day the person does 45 to 1 hour, and suddenly in some entry, there is 450 entry. So, it is also an unrealistic data comparative to the other entries. All the other entries, if you see, there is an unrealistic entry. So that is your wrong data. So how to handle it? Okay. So that we will be discussing now. Correct. So I gave you an unrealistic example. I said, so in that building, all people are staying whose annual income is in the range 10 to 20 lakhs, suppose everyone. But there is one family, okay, whose annual income is 1 CR. So suddenly that has become an outlier. It is not fitting in this category. Everyone is 10 lakh to 20, 10 lakh to 20, and someone is 1 CR. Suddenly, it is an outlier. That person is not supposed to stay in that society. He has to go into some high class people. Getting where everyone is in that one CR category. Right or no? Generally, that is happening. Okay. So outlier, I hope you got it. Right? I said like mom has asked everyone how much chapatis you are going to eat. Everyone on an average one, two, three, one, two, three. And someone in your house member is saying, no, I'm going to eat 15. It is suddenly an outlier, unrealistic data. Correct? So I just want to tell an example of unrealistic data. So you have to remove that. Here you have to do it by some knowledge, by applying some rules. You will apply some rules and all, by applying some common sense and then removing it. Okay. So wrong data refers to records that are successfully loaded. Correct? Meaning they are not empty. The data is not blank. It is not nan or nat. Okay. And the data is in the correct format also. Where you're supposed to enter numbers, it is number only. See, all are numbers 60, 60. So 450 is also a number. So it is not, we cannot say it is an wrong format. All are integers. That number is also an integer. It is not even blank, it is integer also. Okay, so we can say they are not blank, they are in the correct data type. Data type is also correct, but contain incorrect information. The value is not acceptable. The value is unrealistic. For example, where you are supposed to enter 199, where you are supposed to enter 1.99, by mistake you entered 199. One dot is missing. Means obviously all values are in the two decimal places. All are in the range like this 5 point something, 2 point something, 1 point something, like that. And suddenly someone forgot to put point only 199. Dot. So is this an outlier? Does it belong to this category? No, they all are single digit with some decimal, and this is directly a three-digit number. So that one outlier may create inconsistency in your statistical output. Whatever statistical results you want, that you may not get what you are expecting. Getting? Right? So you can often spot wrong data by understanding the domain expectation. Means here I said your common sense is to be applied, knowledge is to be applied. Okay, so if you understand that column, which column? Duration column. And if you see that duration, all durations are in the range 30 to 60, 30 minutes, 45 minutes, 60. And in that whole column, suddenly if you see the value which is not in that range, it is an outlier or it is a indiscrepancy. So you have to remove it. Correct? So you can often spot wrong data by understanding the domain expectation. Domain expectation means you got the possible values in that column, the range, the minimum, the maximum. So in the example data set, whatever data, workout data set, you can see row number 7, you have entered 450. While if you understand the domain of that column, if you consider the domain of that column, in that column, you can see nearly all values are in the range 30 to 60. So it is highly an input typo. Typo means giving a wrong input, right? Which used to happen in past days in your examination system. Many times data entries used to happen wrong. Some in the hurry when they were supposed to enter 19, okay, they enter 91, they enter 90. And maybe one person's career may get spoiled, right or no? It happens. And it has happened. With 30 years back, I remember one girl got 100 and 100 in physics and chemistry, and biology she got 90, which was obviously not 19, it was 91 only, which afterwards too, she applied for recheck and then she applied for the hard copy and all. Then she got to know that there was a data entry, and then, but for that much duration, she had gone through the pain. No? Pain means that mental pressure and all those things. So that was input error. Okay, so that's what now in the examination, everything is now going to become digital, less of pen work. Getting? So it is a typo error, a typing error. You were supposed to enter 45, but by mistake you entered one more zero. Okay, so how to remove this? That we have to discuss. Okay, so one way is replacing values directly. I hope you know LOC, ILOC, and LOC. LOC you can access by the row label. Whatever the row label is, give the row label and you can access it. And ILOC, you can access it by the index number. First is zero index, one index, like that. So to the row, if you have given row label, you can access by row label or by the index also. So directly go to that row and replace it. Okay. So strategy one, replacing values directly, right? But again, then this becomes very much difficult if it is large data set. And in that large data set, to find out such values and replacing, find such value is a tedious task. Then you can write a logic. You will write a loop, and that loop will go on checking each and every value, whether it lies in your expected domain. If it is not in your expected domain, replace it with something. Correct? So that way also you can do. It's called as rule based replacing. And this is directly replacing. Okay. So if the data set is small and you know exactly where the value is to be put, you can replace the cell content directly using LOC property. So to LOC, you give the row number and then next square column number and directly store the value over there. See, like this. df.loc, the row label and the column label, comma. It's a 2D form. No? Data frame is a 2D, right or no? Each column is a series. So you give the row label and the column label. Go to that cross section, that intersection, cross section, that intersection, and store the value there. This LOC we have seen in second lecture, I guess. How to access values from a series, how to access value from a data frame. So DF, and I told you one more, that is ILOC also. So give the row index and the column name and assign new value. Directly it will go and store there. See, in our case, is it going to row number 7 and column duration? Column name is duration, row number is 7, and directly we are storing 45 over there. So manually correct the entry in row 7, duration column, 450 to 45. But this is okay, this way replacement. If your data set is small and few values are out of the domain, few values are wrong, means they are not into your expected domain, then it is okay. But if the data set contains thousands of values, then to check in that column, in that entire column, is the value out of the domain range. It is not in the expected domain. So you have to do it on the rule base. You have to write a loop and then each and every value you check whether it is within the limit. If it is out of the limit, then replace it with the standard value. Getting? So how to do that? That also I'll tell you. Before that, in this case, we will check. See now. In this only, I'll continue. I'll write df of row number 7 and calories, sorry, duration column. I'll replace it with 45, which is 450. I'm replacing it with 45. And now again, I'm printing my data frame. Okay. Now you will check that this way you are not supposed to do, guys. Dot loc and then do it. Through loc you can access, right? See, seventh row, it should replace it. Manually you're correcting it. Spelling is relevant. Duration. It is got it. See, I didn't scroll down. Okay, see, you can check. It is changed. I didn't scroll down and I was checking this only. It's perfectly fine. See, it is done. See the last data frame. This one. Is that seventh row 450 replaced with 45? Okay, so that is one way. But this is okay, no? When one or two values are in that column are not in the domain range, and replacing them with this is okay. And the data set size is small. But if the size is large and there are many values which are wrong entered, to correct them with this way is not okay. Then you have to write a logic. You'll write a loop and do the work. If you don't want to write loop, then you can use apply, map, lambda functions you can use. I hope you remember lambda functions you have studied in basic Python. Okay? So you can create a lambda function and apply that lambda function to each value in that column. You'll create a lambda function, and in that lambda function will check whether the value is greater than 60 or less than 30. Yes, replace it by 45. That logic you will write in a lambda function, and then you will apply that lambda function to each value in the row, in the column. To each value in the column, you will apply that. So you are writing, your logic of writing for loop will get avoided. How to do that also I'll show you. Okay. So this second strategy we will be learning in the next session. That is rule-based replacement. So each and every value will check whether it is below 30 or above 60. Yes, replace it with 45. Okay? Okay. So that how to do it, that we'll be discussing in the next session. After this, then the fourth part will be remaining, that is removing duplicates. So how to remove duplicates, that I'll tell you. After doing that, then we will be learning about grouping, then applying the aggregate functions, then the group by concept. Then we will be learning joins, how to join two data frames. So that all in the remaining part. Okay? Okay, guys. So for today, we will take a pause over here.